Hello everyone, welcome to today's lecture. It is based on pressure sensor and biosensor. So what is a pressure sensor? Pressure sensor, as the name suggests, it is used to measure the pressure. It can be pressure of a liquid, pressure of the gas chamber, like that. So pressure sensor, it is mainly classified into three types. One is absolute pressure sensor. It measures the pressure relative to the vacuum. If you consider vacuum is at zero pressure, then absolute pressure will be the pressure with respect to the zero pressure. Then next is gauge pressure sensor. It will measure the pressure relative to the atmosphere. For example, blood pressure. Then differential pressure sensor. It will measure the pressure difference between the two gas chamber. Okay. So if you see the pressure sensor arrangement, here we have a membrane, or we call it a diaphragm or cantilever. Okay. So this is a flexible material made up of either metal or plastic. The top of these, from now on I am addressing it either membrane or cantilever. So the top of this membrane, let's say it is at vacuum, and from this pressure port the pressure is coming. The pressure is coming from the pressure port, like from a gas chamber, for which we want to measure the pressure. So from this pressure port pressure is coming, and what I told, the top side of the membrane it is at vacuum, and the bottom side some other pressure, okay, which is connected to the gas chamber for which we want to measure the pressure. Now obviously there is a pressure difference between the top and the bottom surface of the membrane. As a result, there will be some deflection in the membrane. For example, if your membrane is in this way initially, so when it is under pressure it will become a bulge, like it will experience a ballooning effect. Now let us say the thickness of this membrane is h and the length of the membrane is 2a, and if the length is 2a, then the distance from the center to the periphery or edge is small a. So from the theory of plates, there is a relation between the pressure, difference in the pressure, and the deflection. So what is it? It is telling P equals to E multiplied by h to the power 4 by a to the power 4 into 4.54 into, this is W0 by h plus 2.33 into W0 by h whole cube. Okay. Now, if you consider this W0, it is the deflection of the plate. Okay. Now, if you consider this Young modulus, obviously it is a constant. Okay. H and A, they are the geometrical properties. Now, W0 is a deflection of the plate. Now, if you consider this W0 by H, it is much less than 1. Then this W0 by H whole cube, this term we can neglect from this expression. In that case, we are getting a linear relationship between the pressure and the deflection of the plate. Okay. So in a pressure sensor, what we have, this yellow color thing that you are observing here, that is your membrane or the diaphragm or your cantilever. Now from this pressure port the pressure is coming at the top side of the membrane. Let us say it is at vacuum, and from the pressure port the pressure is coming. This pressure port is connected to some gas chamber for which we want to measure the pressure. Now what happens if there is a pressure difference between the top side of the membrane and the bottom side of the membrane? Due to that there will be some deflection in the membrane. Usually as membrane we are using the silicon, because this Young modulus of the silicon, the deflection of the silicon, they are very well known and standard. Okay. Now on this cantilever we are placing a sensing element. Okay, so this sensing element can be either piezoelectric or capacitive or piezoresistive. So, in case of piezoelectric type pressure sensor, we have this membrane. I haven't shown here that the bottom side of this membrane, it is connected to the pressure port from which the pressure is coming, and the top side it is under vacuum, and at the top of this membrane a piezoelectric sensing element is kept. Usually we use the PZT, which is the lead zirconate titanate material, as the piezoelectric material. So when the pressure comes from the pressure port, due to the pressure difference between the top and the bottom surface of the membrane deflects, and the piezoelectric material that is kept above the membrane, it is also under the same stress or pressure. As a result, it will generate some electric voltage. Okay, so this is the property of this piezoelectric pressure sensor. And in capacitive pressure sensor, what we have here, we have this violet color. Here it is shown the diaphragm or membrane, and the top side, let's say we have another metallic plate. So from the bottom side of the membrane the pressure is coming, and at the top side we have the vacuum. Okay, so when this membrane is under the pressure, what happens? Due to the difference in the pressure at the top surface of the membrane and the bottom surface of the membrane, this membrane will be deflected. As a result, the separation between the top plate and the bottom membrane will be different, and the capacitance will change. If we measure the change in the capacitance, we can measure how much is the deflection of this membrane and how much is the pressure. Here also in the piezoelectric type sensing, if we can measure this electric voltage that is getting generated from this PZT material, we will be able to know how much is the deflection of the membrane and how much is the pressure. Next is piezoresistive sensor. So here a fabricated image of the piezoresistive sensor is shown. So on the top of this piezoresistive sensor, what we have the resistance that are connected. Okay, so all these resistance, they are in the form of, let's say, Wheatstone bridge. Okay, so this R1, R2, R3, R4, all these resistance, they are in the form of a Wheatstone bridge. Let's say this is R1 initially, this is R2, this is R3, this is R4. So we know when R1 by R2 equals to R3 by R4, that time bridge is balanced. That means the voltage difference between this point and this point is 0. Now, let us say that if the sensor is in such type of arrangement where, if let us say for example all these resistance values are R. Okay, now this sensor is in such type of arrangement that if the change, whenever the sensor is under some pressure, we have this membrane or cantilever, right? So whenever it is under some stress or pressure, what happens? It will undergo some deformation. Okay, so that deformation means if there is a change in length per unit area. So in that case, the system is in such an arrangement that here, if there is del R resistance is getting increased, then in this arm also del R amount of resistance is getting increased. This is due to the deformation happened. And here if it is R minus del R, it will also be R minus del R. Okay, so using some voltage divider rule, we can find out the voltage difference between this point and this point. So what will be my output voltage? Main voltage into this resistance, which is R minus del R divided by sum of this resistance and this resistance, that is R minus del R plus R minus del R plus R plus del R minus main voltage into this resistance, which is R plus del R divided by R plus del R plus R minus del R. If we take the mod value, we will get V0, that is output voltage, equals to V in multiplied by del R by R. So this R value we know because we have only placed or fabricated this arrangement. And this V in supply voltage also we know, and V0 output voltage value we are measuring. So we can easily calculate the del R. Once we find the del R or change in the resistance, then we will easily be able to know how much is the deflection of the membrane or cantilever, and we will easily get to know how much is the change in the pressure. Next topic is biosensor. So what is biosensor? Biosensor, it is an analytical device that measures the concentration of an analyte in any kind of biological sample. So this biological sample can be your body fluid, saliva, sweat, tear, anything. In the food processing industry also, biosensors are finding their applications to measure the pH level of the food. There they do some protein detection or that kind of stuff. In agricultural industry also, biosensors are widely used to detect the presence of the nutrients. Okay. Now, when you go to a doctor can't diagnose you immediately without a sensor. Okay, so the simplest sensor every doctor carries is the stethoscope, which is a sound sensor. Stethoscope is a sound sensor. So what is a biosensor? Biosensor is basically a transducer that will convert the physical or chemical property of a signal into the electrical signal. So biosensor, it is basically a transducer that will convert the physical or chemical properties into an electrical signal using a transducer. Okay, we know transducer, it converts one form of energy to the another form. Okay, so the output of the transducer will be given to the amplifier circuit. The amplifier circuit will amplify the signal. Then there will be a processor which finds out the analyte concentration from the signal that will proceed, and this analyte concentration will be displayed on a reader instrument or a displaying device. Okay, so here what is the analyte means? Okay, analyte is your, suppose you want to detect the glucose concentration in your blood. So here analyte is the glucose, and what is the biological component? Biological component is a biomolecule through to which this analyte will bind. The biological components or biomolecules can be enzyme, can be protein, can be DNA, like that. So when this analyte it binds with these biomolecules on the sensing surface, it will convert the electrical or chemical properties into some electrical signal. So that happens on the sensing surface. So the output of this transducer, which is my electrical signal, it will be amplified by an amplifier circuit. Then there will be a processor which will find out the analyte concentration from the signal that will proceed, and that analyte concentration will be displayed on a reader instrument or a displaying device. So for example, I want to detect the glucose concentration or glucose level in my blood. So for that, the blood sample from my body will be taken, and in the sensor it will be acting with a solution called polyvinyl alcohol. So when the glucose acts with the polyvinyl alcohol solution, it will generate the hydrogen peroxide or H2O2. Okay, now in this arrangement we are using a we are using a top electrode as platinum electrode, and we are using a bottom electrode called silver chloride electrode, which acts as a reference electrode. Now when we are giving the potential at the top platinum electrode, the hydrogen peroxide that is getting generated upon the interaction between the glucose and the polyvinyl alcohol, those hydrogen peroxide will get electrolyzed, and these H plus ions will be attracted or accumulated towards this platinum electrode. So a potential difference will be created between this top electrode and the bottom electrode, and a current will be flowing between them, between the two electrodes. So if we can measure the value of the current, we can easily get to know what is the glucose concentration in my blood sample. So, as I told, what is the mechanism? First, the analyte. Here, the analyte, let's say the glucose in my blood. So, that analyte will be binding using the biomolecules, which is represented as capital B. So what is biomolecules here? Biomolecules can be enzyme, can be protein, can be DNA. So the glucose will be binding with the biomolecule, and where they will bind? On the surface, on the sensing surface of the sensor. So based upon the interaction between the analyte and biomolecule, the sensor will generate the output signal in the form of current or voltage. One, that means this output signal will be in the form of the electrical signal. So once we measure these electrical signal, we will be get to know what is the concentration of the analyte in the original sample.